Okay, this is going to be real short and sweet because it's really hard to show you this without graph paper. So I'm just going to show you how solving by graphing works in theory. Now in chapter 5, you focused a ton on, hopefully, this formula, y equals mx plus b. Once I learned this is the only way I have ever graphed because it tells me m is my slope and b is my y-intercept. And when you're solving systems by graphing, you always want to get them in this format, this y equals mx plus b format. The whole reason you learned how to solve for variables back in 7th grade and then again this year was so you could get things in this y equals mx plus b format. The best time in general to use this method is if they are already in this format. I will tell you personally, this is one of my least favorite ways of solving systems just because I don't usually have graph paper handy. You don't always want to, you have to have graph paper or a graphing calculator in order to use this method effectively. The reason is, here's an example. If you are given y equals 1/2 x plus 2, and you're also given y equals negative x minus 1, this is one where you might want to consider solving by graphing because they're already in that y equals m x plus b format. So you already know 1/2 is my slope and 2 is where it crosses y. And I already know here negative 1 is my slope and negative 1 is where it crosses y. Here's where you almost have to have graph paper and a ruler to use this method effectively. Because as you see, mine is not going to turn out very nice. But this first one, it's crossing at 2, so I'll plot that 2. My slope is 1/2, so I'm going up 1 over 2, up 1 over 2. And then you really, again, you have to do this with a ruler so you can nicely make a line. Because then here's my other equation where I've got my slope is negative 1, it's crossing at negative 1. So there's my negative 1, and my slope is going to be down 1 over 1, down 1 over 1. And then I would attempt to draw that line. When you solve by graphing, you're finding their intersection point. So the answer to this is negative 2, 1. And you can see based on my picture, I almost got it where I was supposed to, but really this is the point where those two lines should have crossed. When you solve by graphing, your answer is always the intersection point. If the lines don't intersect, then there wouldn't be an answer. So when you solve by graphing, your solution is intersection point. So when they cross one another, wherever that is happening, that's your answer. Now, as you know, when you have two lines though, if they don't intersect, they could be parallel. If they're parallel lines, you should know from before, parallel lines have the same slope. So if you run into this situation, since they're parallel, they're never going to cross. So that means that your system has no answer. That won't happen often. We usually like to give you ones where there is an answer. But if you see this, you should know there's no solution. The only other thing that could happen is if they happen to be the exact same line. And this is another just weird case where you would actually have infinitely many answers. So again, just to kind of sum it up, when you're solving by graphing, you're just going to graph your two lines, and where they intersect is your answer.